Hello and welcome to the chapter on network protocols and communications. Today, in one or possibly even three brief little videos, I'll be talking to you about how things work between computers, how the communication process works. And we'll take it step by step. So I'll slide out of the way here and we'll get going. So, first thing we'll look at is what is communication. Now, every model of communication, every speech class you've taken indicates and tells you how you have a message, and then that human communication, that message has a source, which is a person, and it's got a signal, which is the patterns of our voice, and then the medium, which could be the air or the phone lines or whatever it is, and then there's a receiver who signal receiver, maybe that person's ears or eyes, and then the message destination. So there are many ways to get a message across between people. Well, we have a similar model that computer communication was built on. Between any communication between computers, we have to establish a sender and receiver, figure out a way to communicate it, a code, an encoding of sorts. Just as our voice fluctuations encode, so do the patterns of 1 and 0s between computers. We have to think about timing and delivery so that we're not constantly interrupting each other. And then we also have to worry about confirmation. Did I understand you? Or maybe we don't. Maybe we're just broadcasting something. So this is how it works. We have a message source, we encode it, we transmit it over a medium. That medium might be cable or Wi-Fi or fiber. And then the receiving computer gets it, decodes the message, and interprets it in a computer application. So, just as sender and recipient, you have to have an address that has to know where to find you. Computers are a bit of a different situation. We have two different ways of reaching computers. We have what's called a hardware address if it's inside a network. Computers inside a local network can find each other pretty easily. But when it's out on the web, that becomes a little bit different process. And we'll get to explaining all of that. But either way, your computer has to have a sender, which is a source address, and then a destination address, which is the recipient. And then, of course, at the end, you have to have a thank you, goodbye, end of message indicator. Well, computers need that too. So, we have to break down messages in computer communications. Small bits, digital communications, they're packets coming, thousands and thousands of packets handle any kind of communication or phone call. Because computers are restricted by how much information they can carry at any one time. So we string along a lot of little packets of information in the protocols that we use and put it into a separate frame. So, thousands of times per second packets will come to you, but they can all be broken down. And over this course, we'll be looking at how those are broken down. The Wireshark that you download is a great way to see how that happens. And then at the receiving end, all of those separate pieces get put back together. So we have to worry about timing, flow control, method. The flow control is so that it keeps up and keeps listening. If there's a network problem, it hangs up. We do this naturally. We don't even think about it. But when we're having a conversation, we're constantly controlling the flow of our speech. And our timeouts and our responses are all important, and our acknowledgments of when we're finished talking. Now, in computer communications, we have a few different delivery options, and we'll learn about these more. We have broadcast, unicast, and multicast. So this first one here is unicast. In a unicast, we go from one computer to one other computer, just one destination for the message. But we also have what we call multicasting. Say you're watching a movie from Netflix. It's coming from the Netflix server to you and to your neighbor, but not to anybody else. So multicast is one to many, And then the last is broadcast, where we have a message that goes from the source to everybody, a broadcast address. So chances are these modes will have very different setups. I mean, a source from a unicast to one computer, you probably want some back and forth acknowledgement of messages, whereas a broadcast, that's like standing on a mountain and shouting. You're just getting the message out, but whether anybody acknowledges is a different story. So, next section is network protocols and standards. And we have the rules that govern are called protocols. Now, protocols, international protocols, we use those when we have diplomacy and negotiations. There are rules about who can talk to whom and how it works. In our pattern of polite conversation and civil discourse, we use a common language. We wait our turn to speak. We don't interrupt or step over people. And then we tell people when we're finished and let that conversation go on nicely without upsetting anybody, so that everything is understood. So computers do the same thing. Devices share about ways of channeling communication to each other. There's error system recoveries. When we say, "Excuse me, I didn't hear that. Could you repeat it?" Computers need to be able to say that as well. And then also how to end a conversation. Maybe you know somebody who doesn't quite know how to end a conversation. It can be difficult, but you need a polite protocol for how to do it. So, in the computer world, we use these different types of protocols. We use application protocols. For example, HTTP, which is your web browser. That's an application. That communication comes to an application on your computer for a human interaction. But underneath those, we have transport protocols that control the flow of data and the quality and reliability of the data. So that's pretty complicated. Then we have the Internet Protocol, IP, and often you'll see TCP/IP working together because they perform slightly different functions, and they work differently, but they work very well together when necessary as well. And then down at the lower level, we have the network access protocols, data link and physical layers. This is where the actual cabling plugs in and the signaling is on the wire. We have protocols for that as well. So, and we have a whole suite. Now, it's not just the layers, but there are several protocols at all different layers that work together. There isn't just one way to do this. People have been developing different ways to communicate for a long time. So at the lower layers, the network access, we have PPP and Ethernet. You'll learn what all of these are. ARP, and then in the next course, we'll be starting to study RIP and OSPF and EIGRP, maybe even some BGP by the time you get your certification. UDP and TCP at the transport layer we'll be using all the time. And then the application layer, we have email programs, we have file transfer programs, we have the HTTP web programs, DHCP and DNS to help your computer get an address. So these protocols are always working whether we know it or not. The communication rules are in place for us to know. And who develops these rules? You say, well, they're standard organizations. Standards organizations have lots of members, and there are many organizations. I'm just listing a few here. But the Internet Architecture Board has a lot of working groups underneath it, and the working groups take a problem and they work together for a solution. The people that sit on these boards might be engineers from different companies, universities, nations, all send representatives to see how they can work together to solve these problems. So there are lots of societies, lots of conferences, lots of standards. I've sat in on a couple of these meetings, and they can be a little dry, but they're interesting in the way they find elegance. Now here's some of the problems over here on the right, some of the problems that they study. How to make Ethernet better, how to get LAN working better. And these 802.1618, they identify the working group in the comments. So if you just Google those numbers, you'll probably get information on them. So the International Standards Organization came up with the OSI model. And you need to know this. This is something you're going to have to memorize and know very well. You'll know how each layer works by the time you get certified, and you won't get certified if you don't know it. And you can remember this all kinds of ways. You can use a mnemonic, Start from the top down. All people seem to need data processing. That's fine, Or from the bottom up, please do not throw a sausage pizza away. You can learn that way too. But these from the application layer that we work with, all the way down to the physical layer where the transport happens, lots of different things happen. Different protocols work. So the TCP/IP model has to do specifically with the internet. Most of what happens in networking happens in the lower three layers. And then the network access, internet, and transport layers, or internet access, actually. The TCP and UDP are communicating back and forth. Hey, I got all the message, thanks. And then it comes up to the top layers for the application to look at. And there's plenty out, and we'll be talking about what those do. So the physical layer is where the hardware devices and media that make up the network are. So your Wi-Fi, the signaling, the cable, the fiber, that's at the physical layer. And then we have the data link layer. Pardon me. The data link layer is where the physical signals interact with the logical of the network addressing. So those physical signals need to be turned into logical calculations, and that happens at the data link. It links the signal to the processes in the computer. The network is pretty much the internet layer, IP addressing, how to communicate between networks as well, within a local area network and between networks. The transport layer is how things are arranged to be sent between networks and the reliability of those communications. The session layer, we get session layers in flows of communication coming to each other. Every time you open a new browser window, tab anyway, you've got a new session happening. Something has to sort all of those sessions out and keep the flows of communication between applications and browsers and whatever straight. The presentation layer, that has to do with how the application will look. Is it secure? Is it an MP3 file? Is it a JPEG or a PIC? Then we need to do some encryption. That's the presentation, so it can be opened up and given to the application layer where you can use it. Okay? So I'm going to pause right here and move on to part 3 in a separate video because it's getting a little long. So I'm going to stop here and I'll see you in just a few.